Hi, my name's Doug, and I'm here for my star, and we're going to look at how to make the Fidget Spinner Generator System that goes with Unit 7.1 about energy transformations, and systems thinking. So this is part of our system here, this Fidget Spinner Generator. All we have here is a coil of wire. It's held onto this board with a piece of Scotch tape, and two leads coming out of that coil to this light emitting diode, and each lead is hooked up to one side of this diode. So this is our coil LED part of the system. To make it light up, we have a fidget spinner, just a standard, inexpensive fidget spinner, but we've affixed to each arm of the fidget spinner a neodymium magnet. So you can see it's pretty thin. These come in a box like this. This particular one is a box of 20. And what's really nice about these is each magnet has this little sticky dot, and so we can stick the magnets onto the arms, so we can spin it pretty quickly and they won't come off. So to show the system working, I just hold the magnet over the coil while it's spinning, and we get light. So it's really a generator. And as you can see, it's a pretty efficient generator. It makes the light go for quite a long time. The faster you spin it, the more time it will remain lit, the less it flashes. You will see when it slows down, the flashing becomes a little more evident, but it's still light, it's still obvious there's something going on here, and then it eventually stops. But it's a really efficient and good generator, and it's a really good system for the purposes of Unit 7.1. So we're going to look at how to make this. So to make our fidget spinner system, or system model, depending on how we're going to use it, first I'm just going to go through the things we'll need, and then we'll go through the actual construction process. So the things you're going to need are the fidget spinner itself. You'll need 3 magnets to put on each arm, and as I said earlier, this type comes with a sticky dot. We also recommend that you make some with just traditional, or more common, I'll say, less strong ferrite ceramic magnets, and these are just Scotch taped on, but they are much less strong than the neodymium magnets, and that's what students are going to observe. What's the effect of that on the system? The next thing is this coil of wire, and this is going to be, you're going to have to make this, and I'm going to show you how to do that in a minute, but that, as you can see, has 2 leads, and then that is, each lead is hooked onto this light emitting diode, and that's the thing that lights up. So the light emitting diodes are very simple. This is a package of 100 that just cost a few dollars. This is what it looks like, and then we just spread these leads apart and wrap the wires around it. There's no soldering or anything with this system. It's a very simple system to make. To keep this coil in a nice toroid or donut shape like that, I've got thicker wire going around it. You can see you could use tape for that, but this coil of wire really works well for several reasons, so I'll talk about that later. But that's about a 10-inch piece of separate wire. It's different wire than that makes the coil itself. And then the last piece is just a 2-inch by 4-inch rectangle, which could be cardboard. I'm using these Johnsonite flooring samples that I got from my local flooring store. They just had them and didn't need them. They work perfectly for these. That's the final thing on the list. So, as we said earlier, making this coil is kind of the key to the whole thing. Now this is hooked up. It's not taped down, but it's hooked up to this system. And we can take a look maybe at how this works. just so I can show you before it's hooked up. So I'm going to take my fidget spinner that has the less strong ceramic magnets on it, and just take a look here. And you can see maybe that LED is lighting up, not very much, but it is lighting. And then I'm just going to spin the more strong magnets over the coil so you can see the difference. The key is making this coil, so we're going to look at how to do that now. Okay, so to make our coil of wire, we start with a spool of wire that I purchased. We recommend this 36 American wire gauge, which is very thin wire, and you can do it with thicker wire. As a matter of fact, if you have the old MyStar generators, that I believe uses 30 gauge wire, the smaller the number, the thicker the wire. You can use that, but it takes up a lot more space. I can even show you the difference. To get a working coil with that old wire, the 30 gauge, it's about this big, and compared to this big. So it's quite a bit different. So for a spool that you purchase, you can make more coils with this 36, and the 36 seems to be a good size. So now we have to get about 1,000 turns, like 1,000 loops of this magnet wire. So this is copper wire, which is coated with a varnish or an enamel varnish, and that acts as an insulation. So what we want is that the wire to go round and round and round 1,000 times. So we want to spool it off of this spool onto something so we can make this coil. You can do that by hand, but as you can imagine, 1,000 turns is going to be a long time. So if you have a 3D printer available to you, my good friend Jim Hurdle has designed this bobbin in order to wind the coil off of the spool onto the bobbin to make our coil, and even a way to wrap it. So this is just right now hooked up into a drill so that I can run the drill to run the wire onto the bobbin. But this bobbin itself, and I've got a piece of foam in here just to help hold it, but you don't absolutely need that. This is just a two-piece print. So the STL for this is available if you're using MyStar on the document that comes with showing how to do what we're doing here today. And this STL file can be printed into these two pieces. The arbor and the cap. So the cap fits on, and this chucks right into the drill, and then you use the drill motor to wind this up. If you don't have a drill motor, this would even help wind by hand. The arbor, which is this part of the bobbin, the STL file has these little indentations, these marks that go around in a circle right here. Their purpose is so you don't have to count 1,000 turns. If you wind this up, the diameter is going to get larger and larger till the outside diameter is on those marks. That's approximately 1,000 turns, and the right amount you need. So this bobbin is really nice in several ways. So to use it, we just chuck it into the drill, and then the drill will spin it and will spin wire from the spool on to the bobbin. Okay, let's go through winding up a bobbin using a drill motor and the 3D printed bobbin, which is chucked into the drill. Here's my coil of wire, which I just put on a wooden dowel that I had. You know, anything round can work here, but you want this to spin fairly easily. With those neodymium magnets come these little discs that are between each magnet, so they work really nice to allow the spool to turn easily on this dowel of wood, so it comes off nice and easily. So to get started, we're going to take the wire, which again you probably can't see, it's very thin, but I'm going to take about 10 inches of wire, and in the bobbin I'm just going to thread it through one of these slots, and I'm going to take about 10 inches of it or so, and I'm going to tape that to the front. So I just take the coil just to kind of keep it out of the way while we're winding. So I just take Scotch tape, and now I've got about 10 inches of wire just held out of the way on the front of my bobbin. Now when I spin the drill, this wire will start coming off of the spool onto the bobbin. Now, I don't want to go too fast. So once I get going here, I can speed up the drill a little bit, and I just want to keep that wire kind of moving gently across from left to right and right to left, just to kind of keep it even as it spools on. It will kind of do that by itself, but I just turn the drill just a little bit left and a little bit right to get this to wind smoothly. Once I get it winding, I'm just going to keep going and keep going and keep going until I get to those marks. So it's a little hard to see, but on this bobbin are some marks right here where my pencil tip is, and I'm going to wind this coil until it gets out to the outside diameter is on those marks. And I think you can see why this is just a lot faster than doing it by hand. If I had to do all these 1,000 wraps by hand, it can be done. We've done it, but this is so much easier. So when you purchase this coil, this particular one has about 4 ounces of 36 American wire gauge wire on it, and that has about 3,200 feet of wire. One spool of this wire should be able to make about 10 of these coils for the generators, which should be probably enough for one classroom if you have 8 groups and you need 8 of these. Okay, now my wire is all wound on to the bobbin as much as I want. It went all the way out to the marks there. So I've got one end taped in the front of the bottom on the cap, and the other end is still connected to the spool here. So the next step is just going to be to cut this and kind of keep track of those ends, and then what we're going to do, I'm going to show you how to put this binding wire, this one that coils around, it's thicker, and show you how to do that. And that's where this bobbin really comes in handy. So to put my binding wire on my coil, first thing I'm going to do is cut this so that I'm separated from my spool, and then I'm going to take this lead that I've taped to the front here and tape it to this lead. So they're just taped together. Once they're taped together, we can put the helical coil around to bind this. So I'm just going to cut this off And I'm going to leave about 10 inches or so, and then take this off the front, the one I've taped to the front, take that off, tape these two leads together. So I've got my two leads taped together here, so I can keep track of where they are. Now I'm going to unchuck the bobbin with the coil wound on it and show you how we can use this specially made bobbin to wrap our helical wire around to get our final donut shape. So I decided to use a piece of foam in here to hold the cap a little more securely on the bobbin. But now I'm going to take this whole thing off and start the wire to wind around here. So taking this off, remove the foam. I got to hold these two pieces together. I don't want those to come apart because then I'll have wire just every place. But this bobbin is specially made so that I can put wire through these teardrop slots. There's an indentation on the spool so it goes right under the whole coil, and then I can come back through the slot on the other side and basically wrap my coil wire around. And I'm only going to do that 2, maybe 3 times, and then I'll take the coil off and finish. So I'll show you how that goes. Again, kind of holding this all together all the time, keeping the top and bottom together. So my binding wire is probably about 22 gauge, maybe 24 gauge wire. This just happens to be magnet wire. You could also use wire that's got a coating on it. This has copper wire with a plastic coating. It's basically just a twisty tie, right? But you don't want to use like the twisty tie with steel wire in it because that's magnetic. When you spin the magnets near the generator, you don't want them to attract this wire. So copper is what you want. So you need about 10 inches of this. So I'm just going to cut a 10-inch piece. And I start by just putting it through one of these slots and it comes out the other side. And then I'm going to go right back through the same slot. You always go through this one you came out on, because if you go to the next one you'll be wiring the coil to the bobbin, which we don't want. So then I go through here and I'm over the top. Now again, I came through here, so I'm going to go back through the same one I came out. So the wire is being wrapped around in a helical fashion. I came out that slot, so I'm going to go back through the same slot. So I came out this slot, I'm going to go back through this same slot one more time while I'm still holding it all together. So now you can see I've got 2 wraps. And I guess I could just do a third one here. Okay, so I've got 3 wraps on here, which will safely kind of hold everything together. And then I can take my cap off, and I've taped my 2 leads down here together. So I'm going to pull this coil right off of the bobbin using this wire. So this arbor part of the bobbin will just hang here where I've got those taped together, so I can keep track of where that is while I do the rest of this winding just by hand now. So I'm just going to kind of follow that same pattern around, around, around. Now I've got this all wrapped up. I've got some extra wire here, which I could just keep wrapping, but I think I'm just going to snip it off and wrap it around what's left. So I've got my coil made and bound now. I've got the 2 leads coming off. Those are going to be attached to either lead of the LED, and that's pretty much it. Okay, so our coil is done. I've cut off the leads, it's free, it's all by itself. So now we have to hook up the LED to these two ends. I like to leave some wire, maybe 6 or 7 or 8 inches of wire between the coil and where the LED is going to be hooked up. The next step is going to be to remove the varnish, the enamel varnish insulation from these leads, which I don't even know if you can see them on the camera here, but they're very thin. And to do that, we're just going to use a lighter, and we're just going to wave the wire real gently over the lighter flame. And that's all it takes. You will see that it will change color. It'll go from a real shiny copper color to more of a dull color. And that means you've got the varnish off. I just wave it under the lighter and sort of strip it with my fingernails or my fingers. And now we're going to hook it up to the LED. Okay, the next job then is to take these thin wires and wrap them around so I get a decent connection on each LED lead. And I'm just going to take some Scotch tape and tape it to my piece of cardboard, in this case my piece of plastic. It's a pretty simple process once you strip the insulation off the wires, but I'll quickly go through how to do that. So I've got my coil and my thin wires here, so I'm going to take one at a time. I'm going to take my LED and just spread these apart into kind of a V shape. And then all that happens is I take the end, the bare end of the wire, and hold it, the LED, and then just wrap this around one of the leads. Round, round, and round, and round. And this is where I've stripped off that insulation. So an inch or inch and a half, just going to be wound and wound. And then so I take the place I was holding it and wind that around. And I got a decent connection now there between my lead wire and the LED. Now I'm just going to do the same thing on this side. So now I've got the coil and the LED all hooked up. We're really done with the generator system. We just want to fix it to a board, but it's kind of nice to test it at this point, just to see how it's working. But be very careful when you spin your spinner, you don't hit these wires that are loose now, because what can happen is you'll fly this thing across the room and perhaps break a wire and undo a lot of the work that you've just done. But just to test it out, I'm going to take the neodymium magnet here and see that I got a light, which I do, which is great. I've had really good success with these. So now the next job is to fasten this onto a piece of cardboard, or in my case, as I said earlier, I've got these flooring samples. So I'm going to tape the LED onto this lip. These don't have to be great connections. Sometimes you want to undo these. You might want to have your students, do these on their own. So I just simply put a piece of Scotch tape on it, and that's good enough. Now I'm going to tape the coil onto this end of this system. Take this extra wire and just kind of tuck it in so it's out of the way. What you don't want is loose wires sticking up that those magnets, when they're spinning nearby, will grab and throw this thing across the classroom. Your kids might like it, but you probably won't. So once I get that wire tucked in, I'm just going to tape it down, and then I usually put one piece of tape across the middle to hold everything. So I'm just going to do those 2 steps. So one piece, just kind of hold that wire down in the middle. One more piece of tape to hold the coil in place. Again, it doesn't have to be the greatest connection. You could use duct tape or some other Gorilla type tape. I like the Scotch tape or the cellophane tape because you can see everything that's going on. It's thin, it's out of the way, it holds it together well enough. I mean, you can't, it's not super robust, but you'll decide what works best for your kids. And again, now a last test to see that it works, and we always cross our fingers at this point. But I'm going to take my strong magnets, and I get a nice light, and just to try it with the weaker magnets, I get a light, but it's not nearly so strong.